When considering the electrical connections for woodworking equipment, several factors need to be evaluated to ensure safety and compliance with the National Electrical Code (NEC). The primary decision revolves around whether to hardwire the equipment directly or to use a cord and plug connection. If the equipment has a means to disconnect and the electrical panel is within sight, hardwiring the circuit is generally permissible, provided that the ampacity constraints are met. However, there is an exception to this rule. If the cord and plug connection would not be accessible after installation, it should not be used. This provision aims to prevent situations where the connection becomes hidden or obstructed, making it difficult to disconnect the equipment in case of an emergency or for maintenance purposes. Article 430 of the NEC covers motors, motor circuits, and controllers, providing specific guidelines for electrical installations involving motors. Section 430.152 addresses conductor sizing. The general rule, outlined in 430.152a, states that the ampacity of the conductors must not be less than the motor nameplate current rating or the motor controller ampacity, whichever is greater. This ensures that the conductors are adequately sized to carry the maximum current demand of the motor or controller. There are several exceptions to this general rule. Exception number 1 applies to motors rated 1000 volts or less that are not marked with a motor nameplate current rating. In such cases, the conductors must have an ampacity not less than the value calculated in accordance with 430.152 AON or 430.152 ATWR. These sections provide formulas for calculating the minimum conductor ampacity based on the motor's horsepower and voltage rating. Exception number 2 covers motors rated over 1000 volts. Similar to exception number 1, the conductors must have an ampacity not less than the value calculated in accordance with 430.152 AON or 430.152 A3. These sections provide specific formulas for calculating the minimum conductor ampacity for high-voltage motors. Exception number 3 reiterates the rule regarding cord and plug connections. As mentioned earlier, cord and plug connections are not permitted where the connection is not accessible after installation. This exception reinforces the importance of ensuring easy access to the disconnect means. Exception number 4 addresses unbalanced loads in single-phase alternating current (AC) motors. For single-phase AC motors larger than 1 horsepower, the ampacity of the motor circuit conductors must not be less than 125% of the motor nameplate current rating. This additional ampacity is required to account for the potential imbalances in the current draw of single-phase motors, which can lead to overheating and conductor damage. When dealing with a large piece of equipment with an ampacity of 125 amps, it is crucial to consider the disconnect means. Even if the equipment has an internal controller that can disconnect power, installing a separate safety switch is a recommended practice. This provides an additional layer of safety and allows for a complete isolation of the equipment from the power source during maintenance or emergencies. The safety switch should be readily accessible and clearly labeled. When determining the appropriate conductor size for the 125 amp equipment, 430.152 and its exceptions must be followed. The conductor ampacity must be at least 125 amps, unless an exception applies and allows for a lower value based on calculations. The choice between hardwiring and using a cord and plug connection depends on the specific installation conditions and the accessibility of the connection. If the cord and plug connection is accessible and meets all other requirements, it can be a convenient option. However, if the connection is not accessible, hardwiring is the only permissible method. It is also important to select the appropriate type of cord and plug for the application, ensuring that it is rated for the voltage, current, and environment in which it will be used. Twist lock connectors are often preferred for industrial applications due to their secure connection and resistance to accidental disconnection. In addition to conductor sizing and disconnect means, other factors should be considered when wiring woodworking equipment. These include grounding, overcurrent protection, and proper wiring methods. Grounding ensures that the equipment is properly grounded, providing a path for fault current to flow back to the source, which helps to prevent electrical shock hazards. Overcurrent protection, such as circuit breakers or fuses, protects the conductors and equipment from overloads and short circuits. The overcurrent protection device should be sized appropriately for the conductor ampacity and the equipment's current draw. Proper wiring methods involve using the correct type of wiring, such as conduit or cable, and installing it in accordance with the NEC. This helps to protect the wiring from physical damage and environmental factors. It is also important to ensure that all connections are made properly and that all components are rated for the voltage and current they will be carrying. When installing electrical equipment, it is always recommended to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. An electrician can assess the specific installation conditions and provide guidance on the best wiring methods, conductor sizes, and overcurrent protection devices. They can also ensure that the equipment is properly grounded and that all connections are made safely and securely. In summary, when connecting woodworking equipment, it is important to consider the following factors. Firstly, determine whether hardwiring or a cord and plug connection is appropriate based on accessibility and other factors. Secondly, ensure that the conductor ampacity meets the requirements of 430.152 and its exceptions. Thirdly, install a disconnect means, such as a safety switch, for easy isolation of the equipment. Fourthly, provide proper grounding and overcurrent protection. Fifthly, use proper wiring methods and ensure that all connections are made safely and securely. Sixthly, consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. By following these guidelines, electrical connections for woodworking equipment can be made safely and in compliance with the NEC. Always prioritize safety and consult with qualified professionals when working with electrical systems. Consider, for example, the specific scenario of installing a wood lathe. The lathe has a nameplate current rating of 10 amps at 120 volts. The electrical panel is within sight of the lathe, and the cord and plug connection will be accessible after installation. In this case, either hardwiring or cord and plug connection would be permissible. If a cord and plug connection is chosen, the cord and plug must be rated for at least 10 amps at 120 volts. A circuit breaker protecting the circuit should also be rated for 10 amps, or slightly higher, to allow for inrush current. The conductors supplying the lathe must be sized appropriately for the 10 amp load, using the ampacity tables in the NEC. Now consider a different scenario. A large industrial wood planer has a nameplate current rating of 80 amps at 240 volts. The planer is located in a remote area of the shop, and the electrical panel is not within sight. In this case, hardwiring is the preferred method. A disconnect switch must be installed within sight of the planer to allow for safe disconnection of power during maintenance. The conductors supplying the planer must be sized appropriately for the 80 amp load, using the ampacity tables in the NEC. The circuit breaker protecting the circuit should be rated for 80 amps, or slightly higher, to allow for inrush current. It is also important to ensure that the planer is properly grounded to prevent electrical shock hazards. In addition to the NEC requirements, local codes and regulations may also apply. It is important to check with the local electrical inspector to ensure that the installation meets all applicable requirements. Electrical work can be dangerous, and it is always recommended to consult with a qualified electrician to ensure that the installation is done safely and in compliance with all applicable codes and standards. Never attempt to perform electrical work if you are not qualified and experienced. Always turn off the power before working on any electrical equipment. Use proper safety equipment, such as insulated tools and gloves. Be aware of the potential hazards and take precautions to avoid electrical shock. Electrical safety is paramount, and it is always better to be safe than sorry. When dealing with electrical installations, it is always best to err on the side of caution and consult with a qualified professional. They can provide expert guidance and ensure that the installation is done safely and in compliance with all applicable codes and standards. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest changes. This will help to ensure that electrical installations are always safe and compliant. By following these guidelines and consulting with qualified professionals, electrical connections for woodworking equipment can be made safely and efficiently. Always prioritize safety and compliance with all applicable codes and standards. Let's delve deeper into the conductor sizing requirements for motor circuits as outlined in NEC section 430.152. This section is crucial for ensuring that the conductors supplying power to a motor are adequately sized to handle the motor's current draw, preventing overheating and potential fire hazard. The general rule, as stated earlier, is that the ampacity of the conductors must not be less than the motor nameplate current rating or the motor controller ampacity, whichever is greater. This means that you need to determine the motor's full load current, as indicated in the motor's nameplate, and the ampacity of the motor controller, if one is used. Then, you select the larger of the two values as the minimum required ampacity for the conductors. However, there are several exceptions to this rule, which can allow for smaller conductor sizes in certain situations. These exceptions are based on factors such as the motor's voltage rating, whether it is marked with a nameplate current rating, and whether it is a single-phase or three-phase motor. Exception number 1 applies to motors rated 1000 volts or less that are not marked with a motor nameplate current rating. In this case, you cannot simply look at the motor's nameplate to determine the minimum conductor ampacity. Instead, you must calculate the ampacity using the formulas provided in 430.152 or 430.152 These formulas take into account the motor's horsepower and voltage rating, allowing you to determine the appropriate conductor size even without a nameplate current rating. Exception number 2 covers motors rated over 1000 volts. Similar to exception number 1, you cannot rely solely on the motor's nameplate to determine the minimum conductor ampacity. You must calculate the ampacity using the formulas provided in 430.152 or 430.152 These formulas are specifically designed for high voltage motors and take into account the unique characteristics of these motors. Exception number 3, as we've discussed, prohibits cord and plug connections where the connection is not accessible after installation. This exception emphasizes the importance of having easy access to the disconnect means for safety and maintenance purposes. Exception number 4 addresses unbalanced loads in single-phase alternating current (AC) motors. For single-phase AC motors larger than 1 horsepower, the ampacity of the motor circuit conductors must not be less than 125% of the motor nameplate current rating. This additional ampacity is required to account for the potential imbalances in the current draw of single-phase motors, which can lead to overheating and conductor damage. It's important to note that these exceptions are not mutually exclusive. In some cases, multiple exceptions may apply to a single motor circuit. For example, a motor may be rated over 1000 volts and not be marked with a nameplate current rating. In this case, you would need to use the formulas provided in both exception number 1 and exception number 2 to determine the minimum conductor ampacity. In addition to 430.152, other sections of the NEC may also apply to motor circuits. For example, 430.22 covers the sizing of conductors supplying several motors on a single branch circuit. This section provides specific rules for calculating the minimum conductor ampacity based on the total current draw of all the motors in the circuit. It's also important to consider the ambient temperature when sizing conductors for motor circuits. The ampacity of a conductor decreases as the ambient temperature increases. Therefore, if the conductors are installed in a hot environment, you may need to increase the conductor size to compensate for the temperature dirting. The NEC provides tables that allow you to determine the appropriate dirting factor based on the ambient temperature. When selecting conductors for motor circuits, it's also important to consider the type of insulation. Different types of insulation have different temperature ratings and ampacity ratings. You should select a conductor with an insulation rating that is appropriate for the application. For example, if the conductors are installed in a hot environment, you should select a conductor with a high temperature insulation rating. Finally, it's important to remember that the NEC is a minimum standard. You may choose to use larger conductors than required by the NEC for added safety or to allow for future expansion. However, you should never use conductors that are smaller than required by the NEC. Conductor sizing for motor circuits is a complex topic, and it's important to have a thorough understanding of the NEC requirements. If you're not sure how to size conductors for a motor circuit, it's always best to consult with a qualified electrician. They can assess the specific installation conditions and provide guidance on the best conductor sizes and wiring methods. Electrical safety is paramount, and it's always better to be safe than sorry. In conclusion, when sizing conductors for motor circuits, carefully consider the motor's nameplate current rating, the motor controller ampacity, and any applicable exceptions to the general rule. Also, take into account the ambient temperature, the type of insulation, and any other relevant factors. By following these guidelines and consulting with qualified professionals, you can ensure that motor circuits are properly wired and safe.